Once you begin a research project, you might have hundreds or thousands of observations or measurements. What do you do then? Analyzing your data so that it begins to tell a story is a key element of scientific research and includes visualizing techniques such as graphing your data and statistical techniques to reveal patterns and trends in your data that could tell you something about the underlying processes. Raw numerical data rarely tell us anything. For example, in the video on data collection, I talk about a research project in which we are looking at how deforestation in the Amazon rainforest affected the emission of the pollutant mercury from soil. The raw data were simply a collection of numbers, while a highly trained scientist who knew what he or she was looking for might be able to get a bit of information from the raw data table. Generally, collections of numbers like these are not very useful. Graphing the data helps reveal trends that aren't apparent in a review of the numbers. Once we began to graph our data, patterns appeared that were really interesting. The first thing I noticed was a very distinct rising and falling pattern that repeated in the data and is highlighted on the screen. This was great, since I was alternately measuring the concentrations of mercury in the background air, which should be low, and the concentrations emitted by soil, which could be high. This pattern meant that I was seeing what I was expecting to: higher levels of mercury coming from the soil. But there were also problems that the graph of the data revealed. There was a steady downward trend in the values, and the values were all negative. They were less than 0. These trends couldn't be explained by what I was measuring. It's impossible to have a negative concentration of something. I realized that despite the fact that I'd calibrated the instrument, my baseline was drifting downward. Since I was in the middle of the Amazon forest, I couldn't just pull up to my local scientific equipment repair house, so I would have to figure out a way to use the data that I was collecting. I had a few things working in my favor. First, the downward trend in the data was very consistent. So my baseline was drifting, but in a very regular manner. Second, since I was really interested in relative differences between the amount of mercury emitted by the soil and background levels, the absolute concentrations were not important. So the first thing I did was to isolate the low points on the graph. These represented background concentrations of mercury. I graphed these points and added a trend line through those points. Finally, I used the equation for the trend line to calculate a new value for each measurement in my data set. I had transformed my data so that the baseline no longer drifted downward. Now I had data that I could use. The difference between the high points in the graph and the low points gave me a measure of the amount of mercury being emitted from the soil. While I now had useful data, my analysis wasn't over because it didn't yet give me information to answer my question: does deforestation affect the emission of mercury from soil? To understand this, I had to compare measurements I made before trees in the area were removed to those made after the trees were removed. Visualizing a data set is a skill unto itself and involves a lot more than simply graphing the data in a program like Excel. You have to understand what those graphs mean and how they might or might not make sense in a certain context. For example, had I simply graphed my entire data set using a graphing program, I would have seen a virtually unintelligible mess of up and downward curves. Understanding statistical comparisons and tests is key to good data analysis, as it provides a measure of the natural variability or error present in our data. For example, error bars can be added to a graph to show the variability of a specific measurement over time. And statistical testing is often used to quantify the random variability of a measurement and to compare the difference between two different conditions. In our study, statistical analysis showed that the soils on the deforested site emitted more mercury than the intact forest, even when we took into consideration the hour-to-hour and day-to-day variability seen on each individual site. When you begin to analyze your own data, your mentor will be a big help. She or he can suggest different techniques and tools to help you understand and organize your results. But that doesn't mean you can't contribute. You may well notice things that they don't. So go ahead and dig in.